Welcome, viewers. Today we want to continue from where we stopped in the design of composite section. We are still looking at the question in the first part. For those of us who are joining us for the very first time, we did treat how we can be able to determine the number of cables that are required for this section. You can check out that video in part one of these lectures. All right, so today we want to continue. Today we are looking at how we can determine the cable zone of the beam. Zone is very essential because we need to obtain the resultant stressing force, and that force must lie at the centroid of the cable zone. Okay, so we need to obtain this cable zone, and for us to do the cable zone, we must refer back to our equations, which we derive in one of our videos also. In that equation, we establish that for us to have equation P10 and P11 to intersect at equation 6, which is this equation 6. I will have this equation 6. So if equation 10 intersects, which are the critical value for pre-stressing force, economic pre-stressing forces, uh, we said that the operative equation for the cable zone for the upper and lower bar limit of cable zone is 2C and 3C respectively. Okay. And also, if your pre-stressing force lies between P10 and P11, we said we make use of 1C and 3C respectively. And also the same for that of P11. Okay. So, but for what we have done so far, we've been able to obtain our pre-stressing force. We decided to pick a pre-stressing force of 2,500 kilonewton, which we think is okay. We work with that. So if we have that force, we'll discover that that force is lesser than our critical force. Remember, we've solved for our P10, which is the economic limit of pre-stressing force. We've done that in the first video. So we've chosen our P already. Now, if we check the operative equation of the cable zone, is equation 2C and 3C. And that will only happen if equation 6 is lesser than equation 7, so that P10 intersects at this point. Okay, so since equation 6 is less than equation 7, of course, equation 10 becomes the equation, and the operative cable zone equation for upper and lower bound limit of the cable zone becomes 2C and 3C respectively. Now, we also know that on that same condition, we'll have MDB bracket Z1 plus Z1 equal to greater than F maximum minus F minimum, Z1 prime minus Z2 prime. Okay, so that is for a case where we have equation 6 lesser than equation 7. All right, but in a case where you have equation 7 greater than 6, of course, what you are going to have is that this MDB that is greater than F maximum minus F minimum will now be lesser than this. And of course, if you have equation 6 greater than 7, you will have that equation 10 will shift to this side, while equation 11 shifts to this side. Okay, so that is the simplest way to calculate it. Now let's go ahead with what we have. We've already known the operative equation of the cable zone, which is equation 2C and equation 3C. We have it there. All right. So now let's substitute the value of bending moment at various sections across the beam. We'll start with the first section 0, 0, for that is 0. We'll start with section 0.1 L. Let's look at it and substitute value so that we can obtain the required eccentricity at every position along the beam. All right, so we are going to make use of the expression of our eccentricity EX greater than F minimum Z2 over P minus Z2 over A minus MdA over P. All right, so in making do, we are going to look at the position at position 1. Of course, at position 1, we know that bending moment is 0, so we'll have 0, and we'll have it to be ES to be greater than 0.163 meters. Okay, so we have that as the first eccentricity. Now we'll go to the second one, which is position 0.1 L. We have MDA at that point to be 71 kilonewton meters, MDB 64 kilonewton meters. So if we substitute the values into our expression, we'll have that the eccentricity is equal or greater than minus 0.19 156 meters. Okay. All right. So let's look at the position number 0.3 L. Now, if we look at 0.3 L, we can equally obtain the eccentricity in a similar manner. We have that one to be minus 0.23036 meters. Likewise, position 0.4 L will have the eccentricity to be minus 0.23916 meters. The last we have on the board is position 0.5 L, which happens to be the midspan of the beam. So if we do that, we're going to have the eccentricity to be greater than minus 0.2424236 meters. Okay. All right. So have we gotten these eccentricities? We've gotten the lower band limits of cable eccentricity for the cable zone eccentricity. Okay, so the next we are going to do now is to obtain the upper band limit of the cable eccentricity. All right, so now let's look at the upper band limit of the cable eccentricity. All right, so looking at the upper band limit of the cable eccentricity, we recall the equation AS is lesser than Z1 over A minus Z1 F minimum over P. We have it as minus MdA plus MdB over P minus Z1 over Z1 prime ML over P. All right, so we have the Z1 over A to be 0.2023 meters. We have Z1 over Z1. Let's do the upper band limit of eccentricity. We'll look at the position again as we've done before. Recall that position 0.00 L, which is the 0 point. In this case, if we substitute moment 0 at that point, so we'll have 0, we'll have the eccentricity to be an expression of Z1 at the board. If we do that Z1 over A, you'll see that it is 0.2023 meters. Okay, so that is the cable eccentricity at that point. So we can check the others 0.1 L. We have that one to be lesser or equal to 0.020798 meters. We have at position 0.3 L, we have the eccentricity to be negative 0.18815. So we can have that to be 0.18815 meters. All right. So let's take the other position, position 0.4 L and 0.5 L. Once we are done with these values, we'll plot them on the graph, and we are going to obtain the required cable zone for this beam. Okay. All right, let's obtain the last 2 points, which is 0.4 L, and we go into plotting the cable zone. Okay, on position 0.4 L, we're going to have the cable eccentricity ES to be less than minus 0.23127. All right, now at position number 0.5 L also, we're going to work out the cable eccentricity. We'll have it as less than or equal to minus 0.226 meters. Okay, so having derived all this cable eccentricity, the next is to plot the cable zone based on these data which we have obtained from this calculation. All right, so now let's do a sketch of the cable zone. Plot it. You can plot it in your AutoCAD file. We'll do that also on AutoCAD file. All right, so let's do that. All right, so we look at plotting the graph like we have said. Let's see how we can plot the graph. If you see, we've drawn the beam. This is the beam. Look at the sections along the beam. Now we have the graph. Let's look at the values from the table we've obtain the value at 0.1 L, 0.020798. At 0.3 L, we have 0.18815. 0.4 L, negative 0.23. All right, so let's look at the table again at 0.1 L, 0.3 L, 0.4 L, and 0.5 L. So we're going to plot these values like we've said. Now let's plot them on the board. So in plotting the cable zone, the first thing we need to do is to obtain the neutral axis of the beam. And the neutral axis of the beam, we've discovered, we've drawn it at this point. So this is the neutral axis of the beam. From the bottom of the beam to the neutral axis is 0.408. And the total depth of the beam is 915. So what is left is 0.507 meters from the neutral axis to the top of the beam. Now, I haven't gotten this. The next we're going to do is to plot out the points which we have obtained from our equations. We've seen that. So at 0.1 L, at 0.00 L, we have the eccentricity, the upper limit of eccentricity to be here. You can see the asterisks. All right. So and that value is we have it to be 0.2023. Though it's not on that table, but we've gotten it before. So you plot it here at the end of the beam. Now the next point is 0.1 L, and that value for 0.1 L is 0.020798, and that's it. So 0.020 should be around this point. So plot it here. Now the next we are going to plot is 0.3 L. At 0.3 L, the value for the eccentricity is a -1, and that value is minus 0.18815. So if you trace it from minus 0.1886815 should be around this point. Okay. Now the next we'll look at 0.5 L. At 0.4 S, sorry. At 0.4 L, we have the eccentricity to be negative 0.23127. So negative 0.23 should be a little lower than this. It should be somewhere here. We'll mark it. Now the next is at 0.5 L. At 0.5 L, we have the eccentricity to be 0.226, approximately about 0.3 also. So it's almost like a straight line, but we just have it as that. Okay. So once you have plotted this point, this is the first, the upper limit I just plotted. So the next I'm going to plot is the lower limit of the cable zone, which we derived earlier on. So I'll plot that lower limit of the cable zone. Having plotted the points, we draw the curve like we can see it on the board at the curve. Now remember, this is an inequality, so these are the shaded parts of the inequality. Having done this, we're going to plot the second point of the cable zone. We're going to plot that point. Now let's take that point one after the other. The first one is at point 0. At point 0, we have the cable eccentricity to be 0.163. Remember, I'm going to start with the first point at point 0.0. At point 0.0, we have the cable eccentricity in the lower band. At point 0, the lower band to cable eccentricity to be 0.163. So it means we are going to be having that value above our centroid, which is this point. So we'll mark it. Let's call here 0.163. The next point we are going to have is at point 0.1 L. At point 0.1 L, we have the cable eccentricity to be negative 1.91. Okay. Let's look at the next point, which is here. The next point is negative 0.91. So we'll measure from here. Let's call 0.19 here. So remember, we've marked it. So let's draw it. We'll have it here. The next point we have is at point 0.3 L. At point 0.3 L, we have negative 0.239. So we have 0.239. Let's mark it somewhere here. Let's mark it somewhere here so we can connect the curve. The next point we are going to have is at point 0.4 L, which has a value of negative 0.239. So we have 0.239. So approximately almost the same value like we have here. So it's almost going like a straight curve. All right. Now the last we have is at 0.5 L. At 0.5 L, we have it still within that area. So we can say that this represents the cable zone. So I can shade off this part of it. I can shade off this part of it. Now what we have done, we've gotten the cable zone. So what it means is within, this is the upper limit of the cable zone. This is the lower limit of the cable zone. And we have the cable zone width, which is the width between the upper and lower band limit of the cables. So we are not going to take the full beam. We are going to take half because by symmetry, whatever happens on this side of the beam happens on the other side of the beam. All right. So this is how you plot your cable zone for a particular design. Now, I haven't gotten the cable zone. The next phase we're gonna do is plot the cable profiles. All right. But we're going to call it off for today. In our next class, we're going to deal with how we can plot the cable profile for pre-stressed composite beam. Thank you very much for watching. I'll see you in our next class. Have a good day.